Hello, my name is Jaydeep Sai. I am from first year CSC. My topic is mathematical functions in Python. Coming to the introduction, Python mathematical functions. In this module, we will learn about all the mathematical functions available in Python and how we can use them in our programming. So in this module, we will learn about the mathematical functions used in Python and how can we use them in our program. Math module in Python. The math module is a standard module in Python and is always available. To use mathematical functions under this module, you have to import the module using import math. It gives access to the underlying C library functions. For example, square root calculation, import math, math.square root of 4, result is equals to 2. So first we have to import the math in the Python, and again we give input as math.square root of 4. So the square root of 4 is 2. So result is 2. Next, functions in Python math module. Here is a list of all the functions and attributes defined in math module with a brief explanation of what they do. So here are the list of the functions and what they do. First one is ceil of x, returns the smallest integer greater than or equal to x. Copy sign x comma y, returns x with sign of y. Fabs of x, returns the absolute value of x. Next is factorial of x. It returns the factorial of x. Floor of x, returns the largest integer less than or equal to x. So when we see these functions in detail, ceil of x, if we take input as ceil of 2.1, then it returns the smallest integer greater than or equal to 2. So the result will be 3. If we take input as 2.5 or 2.7, then also the output will be 3. Copy sign of x comma y is defined as, if we take x as 2 and y as minus 3, then the copy sign of x comma 2 comma minus 3 returns the 2 with sign of minus. So the output will be minus 2. Next, fabs of 2 returns the absolute value of 2. Next one is factorial of 2. If we give input as factorial of 2, then it will give 2 into 1 and the answer will be 2. If we take factorial of 5, then 5 into 4 into 2, 3 into 2 into 1 will be the calculation and the output will be 125. And next coming floor of x. If we give the input as 2.2 or 2.7, 2.9, then the output will be 2. Next one is f mod of x comma y. It returns the remainder when x is divided by y. Next is fr x of x. It returns the mantissa and exponent of x as the pair m comma e. If sum of iterable, it returns an accurate floating point sum of values in the iterable. Next is is finite of x. Returns true if x is neither an infinity or a nan of not a number. If inf of x returns true if x is a positive or negative infinity. Next is nan of x. Returns true if x is a not a number. Next is index of x comma I. Returns x into I power 2 power I. Mod of x mod of x returns the factorial and integer parts of x. So when we see these functions in detail, f mod of x comma y, if we give input of x is 2 and y is 3, then f mod of 2 comma 3 returns the remainder when 2 is divided by 3. So when 2 is divided by 3, the result will be displayed as output. Next, fr of x of 2 returns the Mintasa and exponent of 2 as a pair of m comma e. If some iterable, it returns an accurate floating point sum of variable values in the iterable is finite of x. It will return the true if x is neither an infinity nor not a number. So if the number is not an infinite or it is not a number, then displays true. Is inf of x returns true if x is positive or negative infinite. So if the input is negative or positive infinite, then the output will be true. Is nan of x returns true if x is not a number. So if is nan of a is a input, then the output will be true because a is not a number. Next is read x of x comma I. It will return x into 2 power I. If we give input as id x of 2 comma I, then it will return 2 into 2 power I. Next one, mod of fx returns the factorial and integer part of x. If we give input as mod of f of 2, then it will return the factorial and integer part of 2. Next is trunc of x. Returns the truncated integer value of x. Next one is x of x. Returns e power x. Next is x m1 of x. Returns e power x minus 1 log of x of b. Returns the logarithm of x to base b defaults to e. Next one is log 1 of px. Returns the natural logarithm of 1 plus x. Next is log 2 of x. Returns the base 2 logarithm of x. Next is log 10 of x. Returns the base 10 logarithm of x. Next one is power of x comma y. It returns x raised to the power of y. So when we come in detail with these functions, trump if x is 2, then trunc of 2 will return the truncated integer value of 2. If we give input as x of 2, it returns e power 2. If we give input as x m1 of 2, it returns e power 2 minus 1. So the result will be e log of 2 into b. Returns the logarithm of 2 to the base b defaults to e. Log 1 p of 2 returns the natural logarithm of 1 plus 2. So the log of 3 will be output. Next one is log 2 of 2 gives the base 2 logarithm of 2. So log 2 by 2 will be the output. Log 10 of 2 returns the base 10 logarithm of 2 power of x comma y. If we give input as x is equals to 2 and y is equals to 3 and power of 2 comma 3, then it returns 2 raised to the power y. So 2 power 3 will be the output, that is 8. Next is square root of x. Returns the square root of x. A cos of x returns the arc cosine of x. A sine of x returns the arc sine of x. A tan of x returns the arc tangent of x. A tan 2 of y comma x returns a tan of y by x. Cos of x will returns the cosine of x. Hypot of x comma y returns the Euclidean norm square root of x into x plus y into y. Sine of x, it returns the sine of x. So we come with the detail of these mathematical functions. If we want the square root of any number, then we should give input as square root of the number in the bracket. SQRT, if for example we take x is equals to 2, then square root of x of 2 returns the square root of x. A cos of 2 returns arc cosine of 2. A sine of 2 returns the arc sine of 2. A tan of 2 will return the arc tangent of 2. A tan of 2 of y comma x. If we give input x is equals to 2 and y is equals to 3, a tan of 2 of 3 comma 2 will return a tan 3 by 2. Next, cos of 2. Example cos of 2 returns the cosine of 2. If we give x is input as 30, then cos of 30 is equals to, it will give output as root 3 by 2. Next is hypot of x comma y. If we give x is equals to 2 and y is equals to 3, then hypot of 2 comma 3 will return the Euclidean form square root of 2 square plus 3 square. Next is sine of x. If we give input x as 30, then sine of 30 is equals to, the output will be 1 by 2. Next is tan of x. It returns the tangent of x. Next is degrees of x. It converts angle x from radians to degrees. Radians of x. It converts angle x from degrees to radians. A cos h of x returns the inverse hyperbolic cosine of x. A sine of h of x returns the inverse hyperbolic sine of x. A tan h of x, it returns the inverse hyperbolic tangent of x. A cos h of x returns the hyperbolic cosine of x. Sin h of x, it returns the hyperbolic cosine of x. If we take x as 2 and give input as tan of 2, it returns the tan of 2. Next, if we give input as degrees of 2, it converts angle x from radians to degrees. Next is radians of 2 converts angle x from degrees to radians. If we give input in degrees, then the output will be in radians, and if we give in radians, then output will be in degrees. If we give a cos h of 2, it returns the inverse hyperbolic cosine of 2. If we give input as a sin h of 2, it returns the inverse hyperbolic sine of 2. If we give input as a tan h of 2, then it will give inverse hyperbolic tangent of 2. If we give input as cos h of 2, then it will give the output as cos h of 2's value in hyperbolic. If we give sin h of 2, then it will return the hyperbolic cosine of 2. Next is tan h of x. It returns the hyperbolic tangent of x. F of x. It returns the error function at x. F of x returns the complementary error function at x. Gamma of x returns the gamma function at x. I gamma of x. It returns the natural logarithm of all the absolute value of gamma function at x. Next, pi. Pi mathematical constant, the ratio of circumference of circle to its diameter, and the value is 3.14159 and so on. Next, value of E is mathematical constant E, that is 2.71828 and so on. So when we come in detail with these functions in Python, if we take x is equals to 2 and give input as tan h of 2, it returns the hyperbolic tangent of 2. And if we give input as if of 2, it returns the error function at 2. So it will give the error which is there in the input. If we give input f of x, returns the complementary error in the function. So instead of x, if we give any function, then if of x or if c of x will give the error in the function which is there in the input. Next is gamma of x. It returns the gamma function at x. If we give gamma of any function, then it displays the gamma. If any gamma function is there in the input, then it will display the gamma function. Next is I gamma of x. If we give input I gamma of any function, then it returns the natural logarithm of absolute value of gamma function in that input function. And another is pi. We have pi value is defined as the circumference of the circle divided by the diameter of the circle. So the value is 3.1415 so on. Next is E. E is the mathematical constant E. It has value 2.7128, so on. Thank you for the sir and the college for giving me this opportunity to speak about the topics given in the Python. Thank you.